In this video, let us see about the logic gates and its truth table. First, let us see what do you mean by logic gate. Logic gate is a basic building block for digital circuit. You can give 1, 2 or more input for the logic gate. So, this input can be 0 or 1. Based on the logic, the output can be 0 or 1. So, only one output you will get. Though you give many inputs, depending upon the combination of the input and based on what logic it is working, it will produce an output of 0 or 1. There are different types of logic gates. The basic gates are OR gate, AND gate and NOT gate. The universal gates are NOR gate and NAND gate. In addition, you have some other gates called XOR gate, XNOR gate. So let us see about these gates and its truth table in this video. First, let us see about the basic gate, OR gate. You see this picture here. The supply voltage is given to a lamp through two switches A and B. We know that whenever one switch is closed, the lamp can glow. That is, the current will flow in the circuit and the lamp will glow. Either A can be on or B can be on, or if both are on also, the lamp will glow. When both are off, when both the switches are in off condition, the lamp will not glow. So, OR gate is based on this. So, when all the switches, that is when both the switches are 0 or when both the switches are off, output is 0. The lamp is off. If any one switch is on, the lamp will glow. It means that you will get output. So, when one input is 1, output is 1. So, if you see the truth table, A and B are the input and C is the output for different combination of the input. That is, when both the switches are off, 0, 0, output is 0. If any other combination is there, if at least one switch is on, output is 1. Here A switch is 1, so output is 1. When both the switches are on, also you will get one output. So, OR gate means at least if one is there, output will be 1. So, this OR gate performs logical sum operation. It means that 0 plus 1 will give you 1. 1 plus 0 again gives 1. 1 plus 1 is also 1. So, we can write C is equal to A plus B. So, this is the symbol of OR gate. A and B are input and C is the output. C is given by A plus B, and this is the truth table for OR gate. Next, we will see the AND gate. So, AND gate, the circuit diagram is this one. So, from AND gate we can say two switches are in series here. By seeing the switch itself, we can write the truth table of AND gate. If both the switches are on, the lamp will glow. If any one is off, circuit is open, no current can flow, so the lamp will be off. So, for different combination of input, you see the output. Only when both the switches are on, you will get a high output in AND gate. So, output C is equal to A dot B. So if any 1 is 0, output will be 0, because this is a multiplication symbol. So you are multiplying these two. When one input is 0, output will be 0. So this is the symbol of AND gate. C is equal to A dot B, and this is the truth table. When both the inputs are 1, output is 1. Next we will see NOT gate. NOT means inversion. So it will invert the given input. So if you give 0, it will give 1 as output. If you give 1 as input, it will give you 0 as output. So inverter symbol, it will be like this. B, you can write it as A bar. Bar represents inversion here. So if you give 0 input, you will get 1 as output. If you give 1, you will get 0 as output. Next we will see NOR gate. Already we have seen OR gate. NOR gate is just inverted OR gate. So in OR gate, so this is OR gate. In OR gate output, if you connect a NOT gate, it will become a NOR gate. So OR gate output, we know it is equal to A plus B. So if you NOT this one, you will get A plus B the whole bar. So the truth table can be, we can find the truth table easily. So you write the different combination of the input. What will be the output of OR gate? 0, 1, 1, 1. Because if any one input is 1, OR gate will give you 1. Now this input, you are inverting it. You are giving this A plus B as input for the NOT gate. So your output will be A plus B the whole bar. So if you find A plus B the whole bar, 0 becomes 1, 1 becomes 0. So for NOR gate, this is the output. So we can see the NOR gate symbol. Same OR gate symbol, you put a bubble here, it becomes a NOR gate. C is equal to A plus B bar, and this is the truth table, just inversion of OR gate. So for if the input is 0, both the inputs are 0, you will get high output, otherwise you will get 0 as output. Next we have NAND gate, which is nothing but the inverted AND gate. That is, you have a AND gate, the output of AND gate, we are putting a inverter. So A dot B becomes A dot B the whole bar. And if you see the truth table, for AND gate, when both the inputs are 1, we will get 1 as output. For NAND gate, when both the inputs are 1, the output will be 0, and remaining all cases, the output will be 1. Just inverted AND gate. So this is the symbol of NAND gate. So it is similar to AND gate, and you have to put a bubble over it. It becomes a NAND gate. Next we have XOR gate. XOR means exclusively OR gate. So in this case, if all the inputs are same, that is A and B are either 0 or 1. If both the inputs are same, output will be 0. And if both the inputs are different, output will be 1. So you can see here, for 0, 0 and 1, 1 combination, output will be 0. If the input is different, input combinations are different, the output will be 1. Normally, exclusive OR will be represented by a, so it is basically an OR gate like structure will be there, that plus symbol. Over that, you are putting a circle, so it is called exclusively OR. and the symbol also it will be similar to OR gate, except that you have one more curve here. This can be written as, the output of XOR gate can be written as A B bar plus A bar B. So how do you get this statement? You see here, this is A bar, second line, when you are getting high output for these two different cases. So here it is A bar, this is B, so this A bar B plus A into B bar is the output. So where you are getting 1, you have to see and write the statement for that. Next we will see XNOR gate, which is the inverted version of XOR gate. So the symbol is same, except that you have a bubble at the end. And normally exclusive OR is represented by this symbol plus inside a circle. Now it is XNOR, so you have to put a bar here. So these two things can be replaced by a dot. Plus symbol has to be replaced by a dot and bar can be removed. So this is XNOR operation. Now truth table, when the input are different, we will get a high output in XOR gate. Here just opposite, when the inputs are same, you will get a high output. So output expression is, you can write it like this, or you see here 0 0 you are getting high output, 1 1 you are getting high output. So I can write it as, what is this 1 1 condition? It means A B plus A bar B bar is the output expression, because for these two cases I am getting high output. So the different logic gates we have seen is that OR gate, which will give you high output when at least one of the input is high. We have AND gate, which will give you high output only when both the inputs are 1. And this is the NOT gate or inverter gate, which will invert whatever you give. It will give you the inverted output of that. NOR gate is actually inversion of OR gate. So the output will be just opposite to this one. 0 1 1 will become 1 0 0 0. NAND gate is just opposite of AND gate. So output will be, here you have 0 0 0 1, here 1 1 1 0. And XOR gate is exclusive OR gate. So for different input combination, this will give you high output. XNOR gate is just inversion of XOR gate. So this will give 0 output when the input are different. If you like the video, do subscribe to Read Electric Vehicle channel, and if you have any queries, you can mail to readelectricvehicle@gmail.com. Thank you. And if you like the video, press the like button.